In this clip, we discuss how a firm in a perfectly competitive market decides how much to produce. This decision process is going to aim at maximizing the profit, or in other words, to produce a given amount of goods with the smallest possible cost. In order to understand this problem, we start with the components. The first component is the cost, which are involved in producing a certain good. In general, firms may have two types of costs. Fixed costs, which are independent of the quantity of goods produced. So these must be paid even if the firm does not produce anything, and these will not increase if the production of the firm becomes very large. These type of costs could be, for example, the rental price of your building or equipment, that is your capital goods. Now, in the short run, we may assume that it is not possible to get rid of your capital goods because it takes time to sell them. That means that in the short run, these costs cannot be changed, so they are deemed as fixed. On the other hand, in the long run, when you can sell your equipment or buildings without any problems, fixed costs will not exist anymore. So in the long run, there will be no fixed costs. Nevertheless, we will look at the short and the long run decision by the firm as well, so it is necessary to look at components of the short run total cost function. Variable costs are the second type of cost. These depend on how much the firm produces. For example, energy use or the wages paid to your laborers is going to depend on how much you produce. So these are components of the variable cost. In the long run, therefore, all costs will be variable. The total cost function in the short run, hence, nothing else than the sum of the fixed cost plus the variable cost, where within parentheses Q simply represents that these quantities depend on the output. We can define two important derivatives of this cost function. The first one is the average or unit cost, which is nothing else than the total cost divided by the quantity produced. And because of the linearity of the total cost function, that also means that the average total cost or unit cost equals the average fixed cost plus the average variable cost. And we will also make use of the marginal cost. The marginal cost shows us how much extra cost incurs if you want to increase your production by 1 unit. To understand the behavior of marginal cost, we need to look at the production process itself. During the production process, the firm transforms inputs, labor and capital in this simplified case, into some good, denoted by Q, using a certain technology. This technology is represented by a production function, and the analog with the utility functions can be seen here. We will not care about the exact functional form of the production function in this course. So again, I just use a general notation that Q will be some function of L and K, and this function is just called F. What we do know, however, that the production technology is subject to the law of diminishing marginal product. This is very similar to the concept of diminishing marginal utility. That is, if you fix, for example, capital, and you start to hire more and more workers, then your production will increase. But as you increase the number of workers, this extra output is going to diminish and decrease. So the marginal product of labor will be positive but decreasing in L. And this is something that we already saw when we discussed the utilities. That is, the law of diminishing marginal product is going to result in our assumption that the production function is concave. Or in other words, we know that capital and labor are not perfect substitutes. Assuming that in the short run the capital stock is fixed and we can only change the number of laborers, that is L, therefore we are going to observe the diminishing marginal product of labor in the short run. Let us assume that all the variable costs are just simply due to the wages you pay to your laborers. We also assume that wages per laborer, W, are exogenously given to you. That is, you are just one of the many firms which would like to hire labor on the labor market. That means that whatever you do not have enough market power to affect wages. Wages, therefore, are just fixed and given to you. In this case, the variable cost can be written as the wage times the number of laborers you employ. The total cost could now be written as FC plus the variable cost W times L. The marginal cost can be expressed then as the first derivative of the total cost function with respect to Q, which is nothing else than wage times the first derivative of the labor employed with respect to Q. But we already seen something like this in the previous slide. Namely, we know that if dQ over dL is the marginal product of labor, then dL over dQ must be 1 over the marginal product of labor. These are just ratios after all, and our algebraic rules for ratios must hold true. This leads to the conclusion that the marginal cost is going to be the wage divided by the marginal product of labor. If, therefore, when the diminishing marginal product law is true, then as you increase Q, MPL is going to become lower and lower. That is, you have here basically a number W divided by another number which gets smaller and smaller as you increase output, noted by Q. That is, as Q increases, the marginal cost must increase. In general, therefore, we can draw the conclusion that as long as production is subject to diminishing marginal product, the marginal cost function must be positively sloped, that is, it should increase with output. There can be special cases when this is not so, but for most of the markets this is true. For most of the firms, diminishing marginal product and increasing marginal cost are going to set a limitation. And in this clip, we are going to look at the standard case. Now we visualize the different cost functions. So we use now, again, a Cartesian two-dimensional coordinate system, with output being on the horizontal axis and cost represented at the vertical axis. We already learned that marginal cost will be increasing in Q for most cases. Here, I chose to represent marginal cost by a line. Nevertheless, it is not necessary that marginal costs are representable by a line. That is, marginal cost may actually increase exponentially instead of increasing linearly like in this case. Average fixed cost, that is, the fixed cost divided by output, are going to be a reciprocal function. So it will start at very high levels, but as you increase output, it's going to converge to zero. So this function, the value of average fixed cost, is going to converge to zero relatively quickly. The average variable costs are increasing in Q. This, again, is represented here by a line. And finally, the average total cost will be a U-shaped curve. So actually we add up a FC and a VC, and that is going to give us ATC, that is the average total cost or unit cost. You can see that it starts out at high levels. After that, it reaches a minimum point and then starts to increase again. This point, where the average total cost, that is unit cost, is the smallest, is the same point where the marginal cost function intersects the average total cost. This point is also referred to the efficient scale. This is that production level at which the firm produces in the most cost-efficient way, that is, with the lowest possible average total cost or unit cost. We look at the optimal choice of the firm under perfect competition. We assume that the firm seeks to maximize its profit. That is, it's going to choose its output, Q, so that pi Q is the maximum possible. Profit will, hence, depend on the output Q, and that's the reason why I use this particular notation. So, pi followed by Q in parentheses only means that profit depends on the output. And profit is simply total revenue minus total cost. The total revenue in this case is just market price times the output of the firm. And price, don't forget that, in a perfectly competitive market, will be fixed and will not depend on lowercase q. This makes the mathematics much easier. The highest possible profit is where the first derivative of profit with respect to output is zero. If you do this, then you will see that because of the linearity of the profit function, you can write the first derivative of the profit with respect to Q as marginal revenue, which in this case does not depend on Q. It is just simply P minus the marginal cost, which in turn depends on Q. So the profit maximum condition is that we should choose an output level at which the marginal revenue and the marginal costs are just equal. In a perfectly competitive market, where firms cannot influence price because there are infinitely many firms, so none of the firms have any market power, the marginal revenue is just the unit price. Let's look at a graphical representation. We have a certain marginal cost function, and we can calculate the average total cost. Now we assume that the market price is P, and this is just a horizontal line. As you can see, I called it marginal revenue, but the point is that because the firm is too small to significantly affect the market price, we can draw simply P as a horizontal line. The optimality condition tells us that we should choose Q star as our output, because at this point, price equals marginal costs. Now you can see that the marginal revenue is actually above the average total cost. This means that per unit it is possible to gain an economic profit. The total economic profit can be represented by the area of this rectangle. So as long as the price is above the average total cost, the firm will make a positive economic profit. This profit can be calculated by just simply taking the area of this rectangle. And this is how you can do it. So you calculate the average total cost at Q star, and then you take simply the difference between the market price and the ATC at the optimum output, and you multiply it by the optimal output again. So far, we looked at the behavior of a firm in a perfectly competitive market in the short run. And by short run, we meant that the market did not have time to adjust. No, we will allow for such adjustments. So the idea is that in a perfectly competitive market, it is possible for firms to freely enter or exit the market. They are going to enter the market as long as there is an economic profit to be made. In the previous slide, we already discussed the choice of the firm with a given level of prices. So at this point, at level P of prices, the firm is going to produce Q star quantity, but in the whole market, which is on the right-hand side of the graph, is nothing else than the sum of all these individual producers. So the total quantity, uppercase Q, is nothing else than number of firms times the firm's output. So N times lowercase q. You can already see that at Q star, the firm still makes a positive profit, an economic profit. Now this will convince other firms to enter this market. But no, the number of firms increases in the market. That is, the supply curve shifts to the right. So we have a positive demand shift, or a positive demand shock. At this new equilibrium, the price will be lower than before, P prime. And at this price, all the firms are going to choose to produce less, Q prime. Nevertheless, because of the higher number of firms, even with this lower per firm output, altogether we have a higher quantity supplied available in the market. And the next point is, when there are so many new firms in the market that all the economic profit is eliminated. This happens at P2 prime, which leads to an even lower output per firm, Q2 prime. At this point, the price in the market equals the minimum of the unit cost. That means that in the long run, all perfectly competitive firms must produce at their efficient scale. But this also means that there is zero economic profit. But remember, zero economic profit is an excess profit above the standard conception of profit, the bookkeeping profit. So it doesn't mean that this firm will not survive at zero economic profit. It just means that relatively to alternative firms, it will not make any excess extraordinary profit. A consequence of this mechanism is that perfectly competitive markets will only allow the most cost-efficient firms to exist and will get rid of the less cost-efficient firms. So altogether, it will lead to the most efficient use of resources, but it doesn't mean that this particular market form is always the best answer and always the best of all possible market forms. In case of the monopoly, we are going to see that there are also merits that can be attributed to non-competitive markets. So far, we had a graphical solution to the problem of the firm's choice in a perfectly competitive market. Now we will look at the solution with algebra. For an algebraic solution, we are going to need a function which represents the total cost. In this case, this is a quadratic function. As you can see, it is positively sloped. The market price will be assumed to be 2 euros per unit of good. Based on this, we can already solve the optimization problem. The marginal cost is the first derivative of the total cost function with respect to q, which will give you 1 plus 0.2 times q. The marginal revenue will equal the price simply because we have a perfectly competitive market. Using the optimum condition, we can find q star, the optimal output, by just making these two equal. And if you do that, you will find that the optimum output is 5 units. The firm will hence choose to produce 5 units. Another possible question is whether the firm makes an economic profit. In order to see that, you will need the average total cost. The average total cost is nothing else than total cost divided by q. At the optimum output, q star, that is q equals 5, we can calculate the ATC, and this is 1.9 euro per piece. Since the marginal revenue is 2 euros, it seems that the firm is going to make a profit of 10 cents per piece. Because 5 pieces are produced, the total profit is 0.5 euros.